Hi YouTube, I'm Nick.
And I'm Joey.
And we've spent the last few months working on electrolysis, and this is our latest and last electrolysis machine.
Now, electrolysis is a process that can be used to drive an otherwise thermodynamically unfavorable reaction.
We used our electrolysis machine to electrolyze water into hydrogen gas and oxygen gas, which can be used to drive a hydrogen fuel cell, or can be explosively recombined.
And there are links in the description to some of our other explosions.
Now that you have a basic understanding of what electrolysis is, we need to talk about what power supply you're going to use to power your generator. I have here a basic block DC power supply that I scavenged from an old camera charger, and you can probably find these just about at any electronic surplus store, and they can put out a fair amount of voltage and current that you can use to power your generator. But the next step up from there is the computer power supply. And these can be quite powerful. You can also get these at electronic surplus stores. And they come with all sorts of computer connectors that we don't really care about. What's important for us is that the red is 5 volts, the orange is 3.3 volts, yellow is 12 volts, black is ground, and you always need to connect the green wire to ground whenever you're going to use a computer power supply. And these can be quite powerful. This one can put out 30 amps at 12 volts, which is enough to even power our big power supply here. But we really like to use the 12 volt battery. And you can use the one that's already in your car, or you can use one separately like we have here. And we like this because it can output a lot of current at 12 volts, which generates all of the power that we need to run our power supply. And an important consideration when building your generator is to balance the physical configuration of the plates inside of your generator with the abilities of your power supply. Most power supplies operate at a set voltage and just output a current dependent on the resistance of your load. So you want to make sure that the insides of your generator are compatible with the voltage and current specifications of your power supply.
The easiest way to regulate the current output of your power supply is to control the conductivity of your water. In of itself, water is not conductive, but you can rectify this through the addition of dissolved salts. However, not all dissolved salts will work well within your electrolysis generator because some dissolved ions produce toxic chemicals when electrolyzed.
I think table salt is like that.
Yes. Table salt when electrolyzed can or will produce chlorine gas at one terminal end. We opted to use potassium hydroxide, but also sodium hydroxide will work just as well because their constituent dissolved ions are both aqueous states and remain so.
And it's also important to remember that even though they're good for your generator, they may not be good for you. So leaving these chemicals on your hands for a long amount of time can burn. So be very careful. And they not only burn your skin, but they can be dangerous to some of the metals you might be using.
We use stainless steel because it's relatively inert to the chemical or to the dissolved ions in which we use. However, other materials such as copper or steel will corrode very quickly with these ions.
Another way to regulate the amount of current drawn from your power supply is to change the physical configuration of the plates inside your generator. So a general rule of thumb for maximum efficiency is 1 amp for every 3 square inches of plate and 1.5 volts for every plate separation. So for our 12 volt power supply, it would be efficient to use about 6 or 7 neutral plates in between the positive and negative plates to help distribute the power from the battery across a larger surface area. It's also important to keep in mind that surface area increases the efficiency of your generator, so the larger the plates, the better, keeping in mind that 1 amp for every 3 square inches is a good rule of thumb. And you can also use this configuration to regulate the current drawn. So increasing the surface area of the plates almost linearly increases the current drawn from the voltage supply. Also, increasing the separation between the plates decreases the current drawn from your power supply. But it's important to keep in mind that if you're using a bunch of neutral plates, you have to increase or decrease the separation between the plates at the same time across all of the plates. Otherwise, you'll have an uneven distribution of power inside of your generator, and you will not have the most efficient generator that you could.
Even the best electrolysis generators only work at around 50 to 60% efficiency. The rest of this power is dissipated in the form of heat. This can be a dangerous situation if you don't have any method to remove this dissipated heat. And the heat has a tendency to collect on junctions such as the terminal ends.
In a previous example of, or a previous rendition of our generator, we used much smaller bolts to generate, or to transfer the power from the outside to the inside. And so much heat built up that it actually reached the ignition point of the hydrogen and oxygen on the inside of the pipe and exploded, breaking our generator. Another important safety measure to keep in mind is the addition of a bubbler. And this physically separates the gas inside here from the gas that you're collecting. For example, if you're filling up a gallon jug and you have a spark in here for some reason, you don't want that explosion to travel through the pipe all the way to your jug, exploding the jug. So the bubbler just adds a nice physical separation. Keep in mind that you want to leave the top of the bubbler open, otherwise instead of adding a nice safety device, you've just added a pipe bomb.
In general, pressure will build up inside of your electrolysis generator.
It's important to change the configuration of your bubbler by adding or letting out water to make sure that the pressure doesn't result in just leaking gas around all of the holes in the top of your generator and actually results in gas where you want it.
You should also make sure there aren't any kinks in your line. One way we rectified this was through the addition of a metal plate to secure the top line coming out of our electrolysis generator.
And now that you have an understanding of all of the things that we kept in consideration when building our generator, let's take a closer look at all of the aspects of the generator that we've just built. Now we're going to show you a closer view of the generator, and we'll go through some of the specific aspects.
Alright, starting from the top, we have the metal band keeping the pipe from kinking.
And as we open it, you'll really get to see a lot of the stainless steel work that we had to do to make this plate stack. The main body of the generator is actually made of 6-inch PVC pipe held onto the stand with pipe clamps. It's not for pressure because we hope to not have much pressure on it most of the time. Explosions are a different story. We also use these nylon threaded rod to separate the plates with nylon washers in between. It's important to keep something non-conductive as your plate separator.
You can see the large bolts we used instead of smaller bolts for optimal thermal dissipation.
And we have L brackets, large L brackets that help distribute the electric current as it comes in from the outside all the way down to the plates. We've also sanded all of the plates inside and out to help increase surface area, which increases the efficiency of our generator. As you come out here, the gas flows all the way through this tube down into the bottom where it bubbles, keeping the gas physically separated, the gas in the generator physically separated from that in the bubbler. The top of this pops off if there's an explosion. It isn't too easy, but we may or may not get it. And the gas finally flows, there we go. The gas finally flows all the way from that top into, or through this tube, where we can collect it in bottles as we wish. Alright, you're recording. Let's start it. There we go. Got the amp meter here.
You can see we're drawing current.
Ooh, we're not drawing very much because that battery's probably pretty close to dead. But we're drawing 4 amps. Oh, and also
bubbles.
We have the plate out of the water so you can just see the bubbles being generated.
And that's probably why the
current's way down.
Yeah, that is.
Yeah, as we put the plates in, the surface area will increase and the current draw will increase. And we're going to cut this video quick, screw the top on, and generate some hydrogen. Now we have the plug all the way screwed on, and we're going to start generating it for real. We'll see how much current we draw this time. It still probably might be a little bit low, just because the battery's nearly dead.
Yeah,
but
it's 3 times the other one.
Yeah, so we're drawing almost 20 amps right now.
That's pretty good.
Yeah.
And you can see the bubbles already forming, or pushing into the bubbler.
And here's the bottom of the bubbler. If I can get a good angle. And then this is the bubbler, just to kind of minimize our explosions. And then that's the final tube there. And we're going to be filling up a little plastic drink bottle.
And we just feed the tube into the bottom of the mouth of the bottle while it's underwater. That way we can displace the water with the generated gas.
Well, this would be a good time for a generic safety statement. Like,
oh, yeah.
Hey, don't
Disclaimer.
Kill yourself. Yeah. Disclaimer, we're not responsible for any of this.
We are partially trained professionals.
No, we're neither of that. We aren't professionals or partially trained. We've just done this. Yeah, but like, I don't know. There's explosives and there's electricity. So like, there's a lot of ways to kill yourself. So don't do any of them.
Oh, and don't forget deadly caustic chemicals.
Deadly caustic chemicals, yeah. Don't drink it.
Please don't drink
or
it.
anything else that might injure you.
And if your hands feel slippery, please go wash them off.
Yeah.
Because bases are slippery. Well, when you feel
them. Don't be an idiot either. Like, these things are very loud. You know, do it on your own property where it won't bother anybody else.
Check out our other video for a proper, or I guess more or less proper, ignition.
Oh yeah, good point. Don't just kind of like light these with a match. They are actually very loud and quite potentially dangerous.
Use earplugs.
Yeah. I see a lot of bubbles forming around the surface here. So this is what happens when Joey doesn't screw the lid on tight enough. I've restarted it. So now we've finished filling up the bottle, and now we have a nice bottle of hydrogen and oxygen to do with what you wish.
I leave a little bit of water in the bottom so that...
Because he's weird.
Thanks for checking this video out.
Feel free to comment or maybe even subscribe.
There are links in the description to some of our other videos.
And keep in mind that we're just college students that spend a lot of time working on this. So if you're an expert in any of this, we'd love to hear from you.
Please leave a... let me see. If I have any questions, drop us a...
Drop us a line.
It's
1988, apparently.
Drop us a line in the... If you have any questions, drop us a line in the comments.
We might even have a VHS tape. Yeah, if you have any questions, feel free to comment and we'll try to answer you as soon as you can. And this is our first video. We're hoping to do more like it. If you have any suggestions for what the videos are like or the content of it, feel free to let us know and we'll try to take that into account.